Alright, so these are the notes I showed you in class, so I would like you to copy these down. I will talk a little about it, so if you are listening. So energy and work are roughly the same thing. Energy is just a version of the stored work. Energy, we use it to do work, so work uses energy. So energy can make things work. However, work can also go backwards. Work can create energy, such as a generator or those wind turbines. A good example is a fan. A fan uses energy to move. However, if we go the opposite way, such as those little windmills, you can use that wind to do work to create energy. Alright, and then remember when we talk about work is equal to the force over distance, so you have to have a force and a distance for work to have been done. So, no distance, no work. Also, if we have to do work, the force is in the same direction, must be in the same direction. So distance and force must be in the same direction. So the harder you push, more force equals more work, or the longer you push, more distance is also more work. So quite simply, to solve for work, it's force over distance. So in this case, we have a force here and a distance here. It's 889 newtons times the distance, 22 meters, equal to 19,536. And this is in joules. So the math on these is not too difficult. Alright, next we have power. Power is in watts. That's our unit. This would be it's a W. Alright, and work is in joules, which is a capital J. And then seconds, of course, is S for time. So the faster something works, less time is more powerful, as well as it says light bulbs give the same amount of work, and they just do it faster. So really, it's how much work you do and how much time you do it. So running has more power than time, although often if you run the same distance, it's the same total amount of work. So the faster you go, the more powerful you are. So an easy example, so power is equal to work over time. We want to figure out how much power there is. We know the work, 520 joules, over the time, 10 seconds. That would give you 52 watts. So finish copying this down, and we're going to do some practice problems. So really quickly, try these on your own, and then come check. So in this one, we ultimately want to find out how much power it takes to do something, which is work over time. It doesn't tell us the work, however, work is equal to force over a distance. We have force, we have a distance. So work is therefore equal to 30 newtons times 10 meters, which gives us 300 joules, and it's in 5 seconds. So we get 300 joules over 5 seconds, gives us 60 watts. Same idea. In fact, almost the same exact question. Looks really similar. Keynote, newtons, kilograms. So it's an extra step. It's still the idea we got to figure out the work is equal to F over D. But remember, work, we can figure out the force of that from finding the force of gravity. So force of gravity is the mass times gravity. The mass is 30 kilograms. Gravity is that 9.8. I'm going to round that. Remember, that's gravity. So now this is 300. So it's 300 now times those 10 meters. So this is, the work is 3,000 joules over that 5 seconds again. So remember, kilograms and newtons are not the same thing. One's a mass, one's a force. And that, therefore, it would now be 600 watts. Got a little ahead of myself there. Alright. Now, this is just a straight work one. Well, work, remember, is equal to a force over a distance. Our force is 25 newtons. We've gone 5 meters. This would be equal to 125 joules. So that's just kind of the basics on how to do it. As you can see, sometimes it's a couple steps. So you know you need power, so you have to find work, so then you have to get the force. So this goes back to our force equations. So here is a work and energy problem. So remember, try it first. Now that you have paused and tried it, so it needs the total kinetic energy before accelerating, so it would be this speed. So the total kinetic energy is going to be the 1/2 mv squared. So it's 1/2 on a 50 kilogram bike times our initial, oops, and I almost read that wrong. I was trying to go fast. So it's not going to be quite 50. We have a 10 kilogram bike and a 50 kilogram person, so it'll be 60 kilograms. And he's going 5 meters per second squared. So solve that out. So that's 25 times 60 times 1/2 is 30. So this equals 750 joules of kinetic energy. Then ask what's the total kinetic energy after accelerating. So now we do the same thing, but with our new velocity. So it's still the 1/2 KE equal to 1/2 mv squared. So that's 1/2 60 kilograms. Now times 10 squared. So that's 30 times 100, which would give us 3,000. So you notice increasing the speed even just a little bit vastly increases your energy. This is why even if you're driving a little bit over the speed limit, that makes the crash that much more worse. Even though you say, oh, it's only 10 miles per hour. Look, that was 5 meters per second. Look at the difference in energy there. Alright, so now it asks how much work was done to increase it. Well, we know work is energy. So really all they're asking is how much energy did you have to add to get from here to here? How much energy do I have to have? How much work was done? So remember, work is essentially equal to energy. So they asked how much work had to be done. So all you have to do is actually subtract how much energy you have at the end by how much energy you had at the beginning, and that was how much energy you had to add to it. If you do the math, that would be 2,250 joules of work had to be done to speed up your bicycle. And then it asks, is it more work to speed up from 0 to 5 or 5 to 10? You can do the math, you can think about it, there's a couple ways. As far as the math goes, if the initial velocity is 0, that means the kinetic energy is 0. So it went from 0 to 750, and then it went to 750 to 3000. Which one took more work? But the second one, because obviously if you look at the math, or if you think about it, velocity is squared. So when this thing goes up, the higher your velocity is, the more change. That's your biggest factor, because nothing else changed. But velocity is squared, so it will have a squared amount of power affecting it, so even more. And I'm actually, last question. Alright, try this one. This is going to use some of your forces and your kinetic energy formulas. So try this first. Alright, so I said force. You're going to need, a kinematics. So here are some of your basic kinematics formulas. So you're going to use some, one, many, I don't know, of all of them and figure out how much kinetic energy. So think of the things you know and what you need to know. Alright, so to do this problem, we need to calculate the kinetic energy formula. That's 1/2 mv squared. We know her mass. What we don't know is her velocity, which is where the kinematics comes in. We do know how much time it takes her 10 seconds. She's gone 50 meters, and she's on Earth. So acceleration, she's falling, right? She's bungee jumping, is about 10 meters per second squared. And our goal, again, is her velocity. So there's a couple ones you could use. You can, in fact, use either this one or this one. I can quickly show you both. So top one's v squared. We want to find it. This is 0. So it goes 0 plus 2 times r this. And she's gone 50 meters, so her change has been 50 meters. So we could solve this, or, which is, I think, is easier to solve, is this one. It's Earth. This is 0. It's Earth, so this is 10. She's been going for 10 seconds. Therefore, her velocity is 100 meters per second. If you want to check the math, 2 times 50 is 100. Now it's come to my attention the math doesn't work on both, and here's why. This looks like someone added it later, and I don't actually think that's right. So, in fact, this would be the correct one to use, because I don't think they calculated that time correctly. So this would end up being 1,000 v squared plus 100 meters per second is way too fast for a person to really should be going. Square root this, and velocity is roughly 31.6 meters per second. Then just go ahead, take this number, put it back up, so it's 1/2 times our 25 kilograms, and 31.6 squared, which if you think about it, it's 1,000. It's right there. So it's 1/2 times 25 times 1,000, which is equal to 12500, so 12,500, and this, remember, is energy, so it would be in joules. Hopefully this was helpful and informative. Tomorrow, just, wear good walking shoes, just in case it's wet out. Alright, and I will see you tomorrow.